Any concept that you want to understand related to this? Or do you want me to explain the concept of correlation and regression? And we will cover these concepts more detail with multiple regression in next module. Whatever you just want, because I'm not including this in final exam. Can you see my screen?
Yep.
Okay. So let me start with a correlation. What is correlation? So just a minute. When you plot, correlation is nothing but a relationship between two variables. So let's say you plot X and Y, these two scales, and when you plot graph between these two variables, it could be like income or spending, it could be other variables too. Simply, let's say this is your income and there is your spending. Okay, let's say you plotted and these are the dots are the plotting. And when you see you can see the pattern in this. This is positive pattern, means income is spending. Income is increasing and spending is also increasing. So this is like a positive. And you can fit a line. So basically, the correlation is nothing but a relationship between two variables. It can start from -1 to +1. Means relationship can be -1 to +1. It could be opposite also, that your income is spending, your income is increasing and spending is decreasing. This could also be possible, that would be negative. So any value of correlation is possible. So R is correlation. This is denoted by correlation coefficient R, and it could be -1 to +1. R can be also 0, means no relationship. What is the meaning? There's no relationship between these. So R is for sample correlation, rho is for population. This is denoted by rho. Okay. So let's see, I'm just going to demonstrate one direct with the data. So share screen, and here, this is the data that we have and we used in our past examples, past classes. So just the same Indian student data that we were dealing. So let's say statement of purpose, letter of recommendation, CGPA, chance of, is there any relationship between these? So one more thing, before we are just in this chapter, we are going to deal with two variables together. How many variables? Only two. This is simple regression. So let's do for only two. So I go under statistics, and here we have regression. Before regression, we need to do a correlation. So there is an option under basic statistics, correlation. Now I choose the two variable to do the correlation. Let's say chance of admission and GRE score. Here we have option, store correlation matrix. You can see in terms of graphs. and you can see pairwise correlation. So all different options are there. I'm going to select multiple so that you can see many other university rating, statement of GPA and chance of. So let's see. So basically you can see the matrix of, so these are the, if you can see, this is, you can't understand much from these graphs, but if you look the very first graph, you can see the pattern. It is close to positive, it is high positive relationship between, I have to see what are the two variables. So the first one, but few correlate, this you can say this is also positive, this is positive, this is positive, this is positive, this, but other, other I'm not able to understand the pattern. So let's do, this is a matrix. Even matrix cannot give you the clear understanding. Now let's come on to the pairwise correlation. So here you go. This is sample 1 and sample 2. And you can clearly see correlation is 0.827, which is 82.7, which is, very high correlation between TOEFL and GRE score. So these are all correlation values. See, is there any correlation value which is in negative? We don't see any negative all correlations are positive of all the things. This is confidence interval of rho, for rho, means this is for population. P-value, now you can understand from P-value. And let me explain. So rho, null hypothesis, say rho equal to 0. Alternative says rho is not 0. You remember we are just using the last module learning. So null hypothesis based on sample, can we say the entire population correlation is 0 or not 0, alternative. Now we prove based on p-value. What do you say based on p-value? Is there, are these correlation useful or not useful? So this is the meaning of useless and this is the meaning of useful. Are you getting me? Now tell me, all based on all p-values that you learned in the last module, which correlation is useful, which is useless? Can you see my screen? Exact learning that you use in the last hypothesis testing, we are going to use same thing here. Okay. Any thought, thinking, idea, guess? Yes, that's correct. That's correct. Everything is, when do we accept null hypothesis? When p-value is greater than the significance level, isn't it? When p-value is more than alpha value, we accept the null hypothesis. That means we say useless. But here we see all p-values are less than alpha value. So we use when, again, I'm going to, when p-value is greater than alpha value, the null hypothesis is accepted. Means And when p value is less than alpha value, this is null alternative hypothesis. So like you are correct that, every correlation is useful because null hypothesis is rejected and alternative is accepted. Is it clear to everyone? Is it making sense to everyone?
Yep.
Okay, perfect. Now we go to so why we check if there is a correlation, if there is a relationship between two variables that exists. So this is the first test before going into regression. If there is a relationship, then significant relationship, then we go for correlation. What is the correlation and regression? So there is a relationship in. Okay, let me make first point. So correlation is simple relationship. What is regression? Regression is causal relationship. So just a minute. Clear. Okay. So now I select, chance of admission as a dependent variable. Means chance of admission depend on your GPA score. Let me see if this is a valid model or I have to check this. So I go under statistics. I have a regression option. I go under regression. I go under fit. So we are just using fit regression model. Why? Because there is also reason. So chance of admission, and before I go GPA. So response variable, and there are many options that you can. So I just, without doing anything, I do this. Now, what is the regression? Before going into this model explanation, I have to explain the concept. So basically, when you have X variable and Y variable, and when you plot these two variables together, let's say you are getting this line. Okay, this is a fit line. This difference or this area or this is called intercept. This is called intercept, means the first value, this is called intercept. Okay. The second value is based on the slope. So how you can get the slope? You just point two values on the line somewhere, anywhere. You just put the 2 point and then draw perpendicular and horizontal lines. So the difference in this, this difference or this divided by this is called slope. So, difference in y means the y2 value and y1 value, which is difference, divided by del x or difference in x. So x2 value minus x1 value. This is difference here. This is called slope. So, or this is known as slope. This is also known as gradient. And this is, so the meaning of this equation, chance of admission depends on this intercept and this slope. This is for only two variables. We are just doing simple regression, means one dependent variable and one independent variable. So chance of admission is dependent variable. GPA or CGPA is independent variable. Okay. And how to calculate, how to understand, this is intercept, this is slope. If this is clear, now Now constant is minus 1.043. I mean, this is one thing. So which is here, GPA slope is 2 point. This is whether these are useful constants. So in regression, again, the hypothesis in regression is null hypothesis. Please pay attention. In regression, all constants and slopes are 0. Are you understanding what I'm trying to say? Alternative hypothesis in this says at least one constant or slope is non-zero. So that if at least one is non-zero means you can have equation that can help you to predict. At least one is one constant or slope. I'm just writing this. Non-zero. Please pay attention. Now, based on that, we have to see which is, again, this is, I would say H0 is useless. This is useful. Now tell me which in this model, which is useful, which is useless. Let's say the intercept, the p-value is 0. Then what you say?
Useful.
Yes, useful. So constant is useful predictor. Useful. What about, whether GPA? GPA is useful or useless?
Also useful.
Very good. So GPA is also useful, means this equation is useful, means GPA is useful predictor to predict chance of admission. So we understand the importance. This is a value of, I already explained this is intercept, this is slope. Now what is this? So when you have these three numbers, you can predict the other number. So let me explain. So coefficient and standard error of coefficient. And this. So basically 1 divided by other, you will get the third value. So how? I'm just going to show. So calculator. Okay, let's do this. So 1.0443 divided by 0.0423. So can you see this is 24 point, I'm not putting the negative sign before. So this divided by this, you get t value. So basically, if you have two numbers in this, you can get the third number. Are you getting me? Means if you have t value, if you have a standard error of coefficient, you get the coefficient value. Or if you have coefficient value, standard error of coefficient, you get t value. If you have, any two numbers, you can calculate the third numbers. This coefficient divided by standard, you get the t value. So this is coefficient. Now model summary. So this is model. This is standard, this model is deviated this much. So this is model deviation. This is R square. Now it's interesting to know what is R square. R square is coefficient of determination. This is represented by R square. This is coefficient of determination or regression coefficient, you can say. What is the meaning of this? 77. So let me 77.87% chance of admission depends on GPA. In other words, I can say, so let me, so chance of admission depend on GPA. What is the meaning? 77.87% chance of admission depends on GPA. So how much? There is also relationship with, in simple regression, R square is R into R. Coefficient of determination depends on correlation coefficient. If you multiply this and this, so let's see, and then I will come. So what is the correlation coefficient between chance of admission and GPA? Let's see from here. Chance of admission and GPA. Okay, so here you can see chance of admission and GPA. What is 0.882? What is the value? 0.882. Oh, sorry. So let's see. So where is the calculator? So look into 0.882 into 0.882. What we get here? 77.8. Here you can see this is the 77.8, the same number. So this is the relationship. This is only valid in simple regression. It doesn't fit into multiple regression. If you have simple regression, correlation coefficient is given, then you can calculate 882 into 0.882, that is R square. Or so what is the value of R square? Value can be 0 to 1. 0 means 0%, 1 means 100%. And Minitab is giving you the answer in terms of percentage. So basically this is 0.7787. So higher is the R value, that means you can have better prediction, means it is better depend on this. What is adjusted R square? So adjusted R square is little bit smaller than R square. Why? I tell you why. So R square, this is 77. This is little smaller, means 77.82, means 0.05 difference. This is another one, so which is more, or this is again more smaller. So look why it is so. The reason is that because of unusual things happened. So this is unusual observation. These are unusual numbers in data that is causing this problem. Means if you remove these numbers in the data, these are unusual observation, means you have to check, is there error in your data, or you have to talk to the person who gave the data, because as per model fit, these are not coming as per model. So what are these? I'm going to explain then. Okay, just so look into this. Let's say this is our X and this is our Y. Let's say this is a model. So this is a fit model line. Now let's say one observation is here, one 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 is going like somewhere here, So what are those, this difference? this difference from model, this difference from model. So model point is this, but you know, this is deviating. So this difference, these are all different residual point or error, or you know, these are the all residual. So these are all residual, means why this is minus, why this is minus is, you know, this side plus is this side. So you can see minus plus sign. So these are the residual number. These are the fit. For this, fit means this point. But you know, this is a residual which is deviating from this. So chance of admission means these are unusual, or this is, for example, let's say somebody is having very high GPA, but you know, chance of admission is 0. That is, something is wrong in the data. So either you need to clean this data, you need to so these are the observations that are unusual, and you can clearly see. Let's say I'm going to be in observation number 10. So 10 is this. Chance of GRE score 323, which chance of admission is 45%, where he has GPA is 8.6. Very high GPA, but only 45% chance of admission. Where he has GPA 8, which is lesser, but here this is chance of admission is more. So this is now one more thing. So understand what is adjusted R square. You know, if you remove all these data in your observation, insignificant or useless predictor, then this R square adjusted will be better. So R square is keeping all in account, all the calculation, but R square adjusted is more purified analysis. R square, you know, this is much more. So we are not going, only these two are important. Now it is analysis of variance. We will talk this in the next BADM 520. This, how I can say if my regression model is useful. So this is another thing. What is the calculated value of, so regression, complete regression is useful. It is determined by F value and P value again. So if I say the P, you know, model is useful or not, what is the model statistics? So the F value is model statistics. You can say this is useful because P value is less than alpha value. And other things I will explain in the next class, which is 520. So this is about regression. There are other principles of regression also, like, you know, Darwin-Watson test or residual, you know, whether residual are normally distributed and other things. So we'll talk in next class. This time we don't have this. And we are going to cover multiple regression also. And this time very simple regression. Now look into one more thing. Excuse me. Now based on this, can I predict something? Let's say I have a GPA of 9. What are my chance of admission? So I go under statistics, regression, and then I have a predict option. So here I am going to give, you know, 7 GPA. What is my chance of? 8 GPA and 9, and let's say 10 GPA. So I have opted all 4 options, and now I am going to do this. This option can only be available once you run the regression. If you don't run this regression model and you are going directly to predict, you will not get this option. First, you train your machine. Okay, this is a model. Then you can use the prediction. So first, before prediction, you also do the regression thing. Okay, let's do. So here, chance of admission, this is when you have GPA 7. this is the value fit. You know, you have 39 or you can say 40% chance of admission. When you have GPA 8, you have 60% chance of admission. When you have GPA 9, you have, so setting 9, you have 80% chance of admission when GPA 9. When you have GPA 10, you have over 100% chance of chance of admission. So basically I did all of them. Let's do the 9th one. So this is GPA. This is chance of so this is I'm predicting for 9 GPA, the chance of admission. This is a standard error in fit, 90% confidence and prediction interval. So confidence interval, you know. So this is based on prediction. And what is the prediction interval confidence? So this is a prediction. So some of the question in fill in the blanks are asking not chance of admission. They are asking prediction interval, lower value, higher value, lower value, and within this 90% prediction will be fine. And this is confidence interval based on population. So this is chance of admission based on 9 GPA. This is confidence interval. This is a prediction interval. These are the two different intervals. Prediction interval. So based on a model, prediction based on the so basically this is based on the sample and this is based on prediction. So this is your regression. Prediction can be only possible when you do the regression. So this is about the module number 6. If you have any question, please let me know. So we are going to have the exam on 24th. If you have any question related to that, I will be happy to answer your questions.
How many questions gonna be on the final?
Yeah, there will be 40 questions in the final.
40. Oh, okay. I
But-
thought it would be 30.
No, we are, I mean, just, 40 question because I would like to make it a standard. Earlier, I used to have 30, now 40 question, and you will have 2 hours time. And instead of having fill in the blanks in MCQ, I'm going to give all MCQ. And one more thing that, concept-based question. No, I'm not. I have, earlier, but I'm going to change. I'm going to have only MCQs. Only MCQs. Oh, 15 to 17. Just a minute. Give me a minute. Okay. Let me see what is the question number 15 and 17. So question 3, 5, 7, 10, 11, 12, 13, 15. So what body fat percentage can a person with a girth 150 centimeter reach? So question number, so basically, like I gave the example, this is a prediction. So basically what is the body weight percentage with 150 centimeter of girth? So like I gave you the example, like 9 GPA, what is the chance of admission? So this is question number 15. Question 15 is just asking you to predict. Okay. Farah? Question, what is the lower bound of average percentage of body weight with 95% confidence for all people who have a girth of 150 centimeter? So lower bound, so basically this is what? For 150 centimeter, it is asking the confidence interval. So one is, and what is the upper bound of percent body weight for a person girth? So basically 15, 16, 17, you just think whether it's asking confidence interval or it is asking prediction interval. So lower bound or upper bound, like I gave you the example in confidence interval. So one is prediction interval, one is confidence interval. So which is correct? So basically what you are going to do for 150 centimeter, you are going to predict what is the lower bound and upper bound. So by default, it gives you 95%. So you don't need to just go. First, you make the model, just predict for 150 centimeter, and you will get the answer of 3 questions directly, you know, from the one step, you will get the answer of 3 questions. Any other question, please feel free to ask. If no, then I will say have a wonderful evening. And after 24th, you can take little bit, you know, break. I think on 12th of July, we will have the summer session, if I'm correct, or my calendar is correct. The summer session of this 520 will be on 12th of July. So we will meet that if you understand this course and concept of this course, you will have very easy ride in next course. Okay. Have a wonderful night. Bye bye. See you in next.
Thank you.
Most welcome.